Hello, this is Dr. Raz. In this video, I would like to show you how to create and understand a trend line with nonlinear relationships. So you can see here that I have 10 years data, revenue data for a drug company, cholesterol drug company. So I could create a scatter chart for this graph by highlighting this column and then insert scatter, and you can see the revenue. And if I just to improve my data ink ratio, I can press delete for those grid lines to increase readability, and horizontal grid lines as well. I could add the axis titles, and y-axis in this case is revenues, revenue in millions of dollars. And my x-axis in this case is year. All right. So now when you see a graph like this, and if I connect these dots by clicking on them, and let's do it one more time, double clicking on those data points, click on fill and line, and you can choose here solid line. Let's choose blue. So now you can see this is the data. However, if I just use a linear trend line to see whether I can explain this data. So what I'm going to do is click on the chart, click on this plus symbol, which is chart elements, and then click trend line, check the box, and click on the right arrow right here, and then click on more options. Now, here when I click on trend line options, currently it's linear. So if I show display equation on chart and display R square value, you can see that my R square value is actually pretty good. However, visually, I'm not really convinced because I see like that most of my observations, especially in this part, are under my trend line. That makes me feel like this could be an exponential relationships. So let me try exponential here instead of linear. So let me just delete the linear line and let me just do it again. Click on chart and at trend line, let me just try exponential and excuse me, and show the equation on chart and the R square value. Okay, so looks like the exponential chart did not really give me a great result. That's kind of surprising, but again, forecasting is something that is surprising, right? So now what I would like to do is try different trend lines. Say if I try logarithmic, this looks pretty horrible to me. Polynomial, actually this looks pretty good to me. Let me see the equation and R square for this. Actually, instead of exponential, I could use polynomial because you see the forecast, it's beautiful, and I can explain 98% of the variation in revenue by using this polynomial second order function. And you can see the function here. Instead of just using linear, which is 90% of the variation can be explained. Exponential, 96. Actually, 96 is better than linear because linear can only explain 90, exponential can explain 96. So I'm okay with, I would say, exponential or polynomial, but it sounds like polynomial is much better. So I would use this forecast for predicting the future sales. But you gotta be careful when you use nonlinear relationships like this, exponential or polynomial and so on, because as you see, there's a square term here. That means that if I go try to forecast 20, 30 years in the future, my number will get so big. What do I mean by that? Let me just show you what I mean by that. So if I just copy this and paste it right here, let's say I would like to make a forecast based on this equation. Okay, so let me just do it again. So I will just copy this and paste it right here. So let's say this is my forecast, right? So if I use this forecast that I have for, let's say, next 20 years for fun, so until year 30, let's see whether this will be a good forecast. Because if I do this, let's replace, this is your coefficient times x squared. X is independent variable, in this case is year, for this specific example year 11, to the power 2, right? I'm just replacing x with year and minus this coefficient times x, which is year, then press intercept. So you can see that my forecast is this. Okay, so now what? Just make all these as dollars, and this one decimal is fine. So now if I drag it up, looks like it's doing pretty well for the past data. However, if I just go in the future, you may see that the sales is growing so fast because exponential growth. You see that 20 years from now, my sales revenue is expected to be like almost 8 times of the current value, which may or may not make sense because companies in general, they grow their revenue so fast when they are in the first phase in their growth phase. However, once they mature up, they cannot just grow with the crazy rate like this. So that's why we gotta be careful about using this kind of nonlinear relationships to make long-term forecasts. That's it for this video. Until next video, enjoy business analytics.